Linearization here. We're looking at linearization, and this is our class is calculus, and today is 12/13 of the year 2012. Okay, and then today we're going to look at linearization. Linearization. What this basically means is we are going to use a linear equation to approximate a value. Okay? We are going to use a linearization to approximate a value. Okay? So we're going to use a linear equation. Question, what's a linear equation here? Yeah, linear equation kind of looks like, there's two forms, remember. In Algebra 1, it was y equals mx plus b, right? Or, you've also seen them as ax plus by equals c, maybe. Okay? And if you remember, point-slope formula was which one? y1 x minus x1. Okay, so we are going to use this one here because we are familiar with it. Okay, we're gonna connect prior knowledge to this graph here, to this one. Excuse me, not this graph. This linear equation, and this is called, remember, point slope form. All right, so what we're going to learn today is the following. So we're going to analyze what we've been looking at here, and we are going to just build this fresh. So if we draw, let's just go ahead and just draw any curve. Let's call this f of x, okay? Call it whatever you want. Alright, so here is f of x. And so, if you notice, so let's just say like, alright, check it. I want you to find the equation of the line at A. Let's call this A. Oh no. I know you can't see it. There we go. That's A. So we scroll up here, and we know this is some point here. So I want the equation. This is what I want. I want the equation of the line at x equals A. Okay? So, you might think, okay, Mr. Roseville, that's pretty, well, I think I can do that. For an equation, what do I need? I need a what? X and a y and a slope, right? Well, I can kind of find this. So this is, I know the x value is what? A. What is the corresponding y value? This is, because this is f, so this is f of A, right? Remember, f of A is just the y, right? So do we agree this is A, comma, f of A? Is that okay? All right. So this means that the x value is A and the y value is f of A. Cool? Alright. So now all I need is what? M. And M is the slope, which can be acquired by the derivative of f at where? At x equals A. So what is the derivative of f called? F prime. Beautiful. So wouldn't it just be f prime of what? A. Is that okay? This means this. True? Is that cool? So then, I know M is what? F prime of A. So what I'm going to do, I'm just going to plug everything into the point slope form now. Ready? Here I go. So I'm going to rewrite it again. Y minus y1 equals m times x minus x1. Now we plug it in. Alright, so what was y1? Oh no. Minus f of A, right? Equals, what was m? F prime of A times x minus what? A, right? So, now this looks similar, so I just want to show you how this is derived. Derived means created, basically, right? So, now, normally we like to solve for y, right? We have this. So what would I have to do to solve for y? Let's just add f of A to both sides here. F, distribute. Just add f of A. So these go away. And I'm left with the final answer here. I'm going to go on this side here, which here, so this is y equals, it's f prime of a times the quantity x minus a plus f of a. True? Okay, and if you look in your book here, this is the definition of linearization. You guys see that? That's all it is. Okay? So this is the equation. So you could use this formula to find the equation of the line at any point A. Okay? So why do I care? Is because you can use that to approximate certain values now. So we're going to do one example. Okay? And then so we're going to do one example here. Okay? There we go. Go ahead.